So, good morning, everyone. My name is Nibras Rakib, and I'm here today to talk about my internship experience. During my internship, I worked on the methods of extracting expertise terms from expert biographies, which were in raw text. I also worked on the generation of expert network using these terms and incorporated this network to web-based user interface. Today, I will start my presentation with the introduction of my lab, where I worked along with my mentor. Also, I will describe the research problem and dataset associated with my internship. Right after that, I will discuss the methods, findings, tools, key stakeholders, the limitation, and the future of the study. I conducted my internship at the Laboratory of Applied Informatics Research at University of North Carolina at Chapel Hill. My mentor is Professor Javed Mustafa from School of Information and Library Science and School of Medicine. He is also the director of Carolina Health Informatics Program and the Laboratory of Applied Informatics Research. The overview of my presentation is how do we extract accurate healthcare expertise terms from raw text, and also how do we generate a network graph based on healthcare expertise. Before I jump into the research problem, I'd like to share a story that depicts why the problem is important. One of the important courses I took during my master's program was healthcare data visualization, and I was trying to find out the current or active contributors in the area and their skills. I haven't found any curated sources that showed the active contributors in healthcare visualization and their skill set. Basically, in any research, particularly in healthcare, findability, accessibility, interoperability, and reusability of data is difficult due to many regulations. Health Data Exchange is an online community for healthcare experts. Health Data Exchange can contribute to achieving the solution of this problem. During my internship, my focus was to improve the findability of healthcare experts using Health Data Exchange. The dataset I was worked on, that's basically the directories from 5 organizations. The first one is the 3 schools and 2 departments from University of North Carolina at Chapel Hill, 1 school from Johns Hopkins University, 4 departments from North-South University, Bangladesh, and a physician network called WakeMate in USA, and the UNICEF, the humanitarian organization. There are 2,584 specialist biography in this dataset. The attributes we extracted through a pipeline using a rule-based approach are name, country, organization, designation, and expertise. The HDX is currently using a data pipeline. The data pipeline has 5 stages. The first one is the data source, where we mention the directories. A crawler and or a computer program search and collect the information from these directories in the second stage. The third stage is all about processing, like extracting the names and the attributes from raw text. Then these attributes are stored in the MySQL database, and this data is consumed by a web-based user interface. My particular task mainly on the data processing part and the consumption of the data, mainly in the user interface. The methods we used of extracting expertise are described in this slide. The first step in the data processing stage, we used several steps, and we are calling it as a pre-ETL process. In the first step, we extract the name, designation, contact information, educational background, expertise, and the publication of the specialist. And in this stage, we actually extract the expertise from a master expertise term list that has been collected from Johns Hopkins University. In the second stage, we did some text pre-processing. For example, we'll work as the terms of expertise. I then remove the stop words, remove any special characters, and we considered the tokens that has at least 3 characters, and reduce the different form of words to one single form. In the third steps, we counted a frequency for each n-gram. The n-gram means a sequence of n words. So, for example, medium blog post is 2 gram. A medium blog post is 4 gram. So we decided the value of n should be greater than 1, but less than or equal to 4. Then we applied Jeeves law on this text corpus that we collected through this processing. Jeeves law is an empirical law that often holds approximately a list of measured value is stored in decreasing order. Namely, it is found that the most common word occurs approximately twice as often as the next common one. 3 times as often as the third most common one, and so on. So we basically try to identify that our corpus actually holds the Jeeves law or not. So we are saying that our corpus follows the Jeeves rule. After pre-processing, in this slide, we are actually seeing the difference between the different value of n. For example, on the left side, we can see there's a lot of expertise terms are there when we are considering the unigram. For example, the n-gram, when we are considering the value of n is 1. On the right side, we are getting more fine-grained expertise terms if we consider the value of n from 2 to 4. So we are considering the right side visualization for our user interface. In healthcare, understanding terms can be difficult for parametric users. As a part of improving the findability, we try to make available the definition of these terms in the user interface. To collect this definition, we considered MESH, medical subject headings from National Library of Medicine. It is basically a thesaurus used for indexing articles for PubMed. To collect this expertise definition, first we collected the expertise from HDX. Then we used MESH API to capture the definition. If the definition is found, we stored that into the health data exchange. In the user interface, we also showed the definition if a user hover on a specific expertise term, if the definition is available in the user interface, a tooltip is appeared and provide the definition to the user. Based on these expertise terms, if a definition is available on the HDX, we generate a network graph based on the expertise. For example, in this slide, we are generating a graph of all the specialists that share a common skill named comparative effectiveness research. And that means that these experts are all shared a common skill. And the definition of these expertise terms or skill, we are also showing that for better readability for the users. The findings from this internship, actually, while we are doing the using the data set, expertise terms that contains 2 or more words is more meaningful, as I showed the earlier slides. And also we have found 314 specialists whose expertise is health policy. We have used several tools like Python, MySQL. We use Python for data analysis or developing the backend part, this API and other stuffs. The MySQL is currently holding all of our data sets. We used React.js and D3.js for the user interface to develop the graphs and charts. And all the services we used, they are hosted in the Amazon Web Services. And that is basically combining all the tools and the languages into one single server. We believe the key stakeholder for HDX would be the university, for example, professors or research partners and public health experts. If they want to form a team based on certain skills, they'll be able to use that. Also, the students, if they want to conduct an internship based on certain topic, they'll be able to find special teachers' information or the specialists who are on the who have a specific skills. Also, physicians network can help it for the patient. From patient's perspective, they'll be able to find nearest specialist if a specific doctor is unavailable. Doctors may also use it if they have long queue of patients. They will be able to use this platform to refer patients to the nearest specialist. Also, humanitarian organizations such as UNICEF or the Save the Children will be able to use this platform if they want to work on a specific topic in a specific country. They'll be able to use this platform to find those experts. We have a few limitations in this tool currently. The dataset is very limited right now. Like we are using almost 2,500 specialist information. We have to still identify a proper rule to extract those expertise. We have to develop a definition if a number of nodes in a network graph got increased. And also limited searching capabilities may hamper users. For example, we want to search with two attributes, the name and their expertise. Currently, it is unavailable to the user interface. Our next step should be like we have to expand the data set with the specialist information. We have to improve the ETL process for updating current data set. And we have to improve the current user interface. And first, I'd like to express my gratitude to Dr. Mustafa for mentoring and also providing the opportunity to work on this project. I'd also like to thank Kolam Kibia as he went through lots of documentation and literature review. Mike Zhang helped us to develop a mobile app, and Abigail Mary Agnes is working on a survey that how we are supposed to improve the user interface. And I think that's it from my side. I'll be able to take any questions if you have. And thank you for your time and patience.